if you guys actually have been drinking 1.5-liter bottle waters at home, please start collecting it already, because we will be using that 1.5-liter bottles to create rockets that we will launch in your chapter 2 pressure. So a reminder again for you guys to actually start collecting it. And when we come back for physical class, you can actually start bringing it and put in the physics lab. Okay, I'll open a corner for you guys to put in. So the minute you have a 1.5-liter bottle, any bottles, but I prefer 100+ bottle. Do collect it, wash it clean, and then bring it to class. All right, wash it clean, dry it off, then bring it to class. Don't bring a not washed bottle to school. Okay. All right, there's 61 people, so I'm gonna start the activity already. Okay. So let's start. I'm going to close this. All right, so we're gonna break down forces today because it's almost similar to our Form 4 Chapter 2 syllabus. We are learning the second part right now in Form 5 Chapter 1. This particular class today is talking mainly about forces. We're not going into resultant forces as what the syllabus is talking about. So right now, I want to understand, again, I know I asked a question in the quiz yesterday, but I want to know again, what is force? Give me example of forces. All right, give me example of forces that you know. Give me the example of forces that you know. All right, good. Is Justin in the class? Is Justin in the class?
Yeah.
Justin, answer this question and get level 1. Football getting kicked. Propulsion force. All right, good. May the force be with you. Okay. Closing submission in 30 seconds, sir. $20 to submission closing. $5. All right, good. Okay. So as you can see over here, I asked a very general and open-ended question. What is force? What do you understand force? Give me an example of force. So the most answer, the one that has keep repeating out is gravitational force, which is good. That's your chapter 3 from Form 4. We have gravitational force, tension, frictional, centripetal, good. Propulsive, elastic, inertia. Okay, inertia is related to force anyway. Baseball getting hit, centrifugal force, magnetic force, electrical force. We have Star Wars punya benda kat dalam. May the force be with you and all of you too. Frictional force, electric force, gravitational force. All right, football getting kicked, nuclear force. All right, good. Anyway, most of you actually understand about forces, but do you really know the details of forces? That's my main purpose for today's class, all right? So, a force is actually something that's capable to change an object's state of motion. This is what you've learned previously in science. A force definition in the syllabus is actually a push or a pull, all right? Let me minimize this. All right, a force is actually a push or a pull upon an object, resulting the object's interaction with other objects. If, let's just say, if you look around you, the objects around you cannot move, cannot change the shape, because there's no force interacting with it. So if you want to change the shape, you want to change the velocity, you want to make it move or change direction, you need a force to make that happen. Okay, so there are four different types of fundamental forces. This is for your general knowledge, not in SPM syllabus. All right, the first is gravitational force. Now, gravitational force that you've learned previously, the force involves interaction between massive bodies. All right, so it's considered a long-range force, and it's actually the weakest force in nature. All right, you might think that gravity is very strong, but if I ask you to jump, you overcome the gravitational force very easily. All right, so that's why it's the weakest force in nature. All right, the gravity of the sun and the star. All right, that's Earth gravity. All right, the next one is electromagnetic force that we learned in Form 5 syllabus this year. Magnetism is actually due to electricity and magnetism. All right, it has attractive and repulsive force between the electric charges. It's considered a long-range force as well. All right, and the third type of force is actually strong nuclear force. This is what you learn in chemistry here. All right, strong nuclear force is actually what binds the protons, all positive charge particles, all being bind up together at the nucleus. All right, that's why it's the strong nuclear force. It's the attractive force that's bonding the neutrons and protons in the atomic nucleus. All right, so that's the third type of force. And this particular force is a short range force, but the strongest force in nature. Okay. The last type of force is the weak nuclear force. Weak nuclear force, again, you learn it in chemistry. Later on in nuclear physics, you will learn it again. All right. Weak nuclear forces is actually the one that's binding the the electrons to the protons, because it's unstable condition for the atomic nucleus and it's responsible for the radioactive decay. All right. So we're gonna learn this at the according to my flow, it's going to be the third chapter of this year, okay? So it's a short range force and 12 times weaker compared to electromagnetic force. All right, so we have four types of forces. This is for your general knowledge. Now, force is a vector quantity. If you recall, that's why yesterday I asked the question about vector. Vector quantity means it has magnitude, and then it also has direction. Right? So it has magnitude and direction, which means that every single time we talk about force, we need to talk about the direction as well. All right, so that is what I'm going to be focusing on today. Force SI unit, all right, this is the base unit. Please take note, this is the base unit. This is the base unit, whereby the SI unit for force is actually Newton. This is the SI unit. Okay, what is a base unit? Base unit is actually from the 7 base quantity, which is time, mass, yeah. We have length. What else do we have? We have current, right? That's the base quantity. Come, give me what else is the base quantity that I missed out? Amount of substance. Amount of substance or amount of matter. 1, 2, 3, 4, 5. What else did I miss? Temperature. Yes, good. Thank you. Luminous intensity. What else? 1, 2, 3, 4, 5, 6, 7. All right, 7. We have the 7 base quantity. All right. their corresponding SI unit is known as base unit. So time base unit is second, mass is kilogram, length is meter, current ampere, amount of substance mole, temperature Kelvin, luminous intensity candela. So the base quantities unit is known as base unit. So the SI unit for force is actually Newton. Kg meter per second square is the base unit. Please take note. Okay. So that's the reason why I asked you guys to have your notebook with you. All right. I want you guys to actually write down this particular notes into your notebook as your memory, because I'm refreshing your memory from the science syllabus, not physics syllabus from Form 4. It's actually refreshing your memory from science syllabus in Form 1, Form 2, and Form 3. It's very important that you refresh all this, because without all this basic, you won't be able to answer some of your physics questions. All right, so that's the reason why I'm taking some time out to refresh all this thing. Okay, I'm going to go next slide. Now, the basic of the forces. All right, so what you need to do from today, hopefully we can cover these three things. Identify the forces that's acting on the body or object in different situations. So we're going to cover about 4 different force: weight, tension, normal force, friction. Then we're going to learn how to draw a free body diagram. Now, this 3 things is actually part of your syllabus that you need to learn. It's just that I reshuffle the textbook a bit. Okay. So the first thing is weight. All right. First thing is weight. Weight is also known as gravitational force. Please take note. Weight is also known as gravitational force. Some students ask me, teacher, what's gravitational force? What's the gravity force? Gravitational force is also known as the weight of an object. Okay? So the definition for weight is actually the force acting on it due to the gravity pull. I need you guys to understand this. Okay? Weight is also known as gravitational force. It is actually the force acting on it due to the gravitational pull. All right. The formula for weight is W equals to mg, where m is the mass of the body in kg, the body, the object, the particle. All right. That is mass. Okay. G is the acceleration due to gravity. And in KSSM syllabus physics, we no longer use 10. Okay. We no longer use 10. We use 9.81. All right. So do not memorize it as 10 meter per second square. And don't use 10 in your calculation, because in your syllabus, they use 9.81 for Earth's acceleration due to gravity. Now, can you tell me what is the direction of the weight? Because weight is a force. Where's the direction of weight? Answer me in the chat room. Where's the direction of the weight? Where's the direction of weight? Hello? Am I talking to myself? Everyone said down, 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 down. Down, 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 down. Okay. So the more exact one, which I'm seeing some of you actually vote, it's correct. Always directed downward towards center of Earth. All right. Always directed downwards towards the center of Earth. That's the direction of the weight. Okay. So if a car is pointing down, even if you are floating or you are free falling on air, you are towards down. So you need to understand one particular thing. Okay. Weight, an object will forever, as long as it is on Earth atmosphere, all right? As long as it is on Earth's atmosphere, it will have one force definitely acting on it, and that's weight. All right. So whatever location it is on Earth, it will have the weight. All right. Always pointing down towards center of Earth. This is what you've learned. The remark is actually from chapter 3 in gravitation. Weight varies slightly with altitude, right? Because weight depends on the strength of the gravity. You measure yourself on the weighing scale in Subang Jaya. let's just say it's 500 Newton. If you go up to Cameron Highland or you go up to Genting Highland on the same day in less than 2 hours, your weight will actually slightly drop. It's not because you suddenly feel lighter. It's impossible, but it's actually because of the acceleration due to gravity that cause it to drop. Because the further you are from the center of Earth, the lesser the acceleration due to gravity. All right. So the greater the distance from Earth, the less the gravity, the strength of the gravity, the less the weight of the object. Okay. So that is weight. Now, let me test you guys. Do these exercises on your notebook as well. All right. And then upload your working. This is actually a recap memory from your chapter 3 gravity last year. All right. There's no time limit for this for the moment, but probably give you guys around 5 to 6 minutes. Do the exercise, refer to your textbook, refer to online or whatsoever. All right. Try to do this working. Alamak. Okay. Yes, inside the notebook, Priya. It's okay. Notebook, no index. Notebook tak payah index. But if you have already done it, just write it as forces and motion. Those who have already created the index and notebook, just write it as forces and motion. Those who haven't, tak payah. For those of you still wondering, I'm giving you guys tips right now. Closing submission at 10 minutes. It's already 7 minutes. Come on, put an effort to try to do the question. I already said you can refer books, you can refer online, you can discuss with your friends. Wait, Vishal, let me try to find your work. I tried to see whether I can resubmit or not, Vishal. I deleted your response, Vishal. You see whether you can resubmit or not. So you have 1.5 minutes to go. One minute left. Wei Hong, okay. Wei Hong, alternative. You can actually do on your. Don't worry about it, Vishal. Okay, it's not a quiz anyway. Those who's using laptop, you can actually do at PowerPoint and then save that picture and then upload that picture if you're using ClassPoint. 15 seconds before I close. Three, two, one. All right. So let's see your friends' responses. If I pick your answer as what I mentioned last year, don't be afraid. We're all in the learning process. Yuanming, good that you actually use this method. Right, I'm going through some of the answers and actually directly putting it into my PowerPoint view. Okay. All right, so let's see over here. Sam has a mass of 67 kg. Find his weight on the surface of Earth. All right, I've already give you guys the acceleration due to gravity, and also I have already cannot change color. Okay, I've already given you guys also the formula. So in this particular case, all right, the working. I'm gonna show you guys the working first. Then I'll go and check some of the working of the friends that I have already chosen just now, and then please learn. All right, please learn together. what is the correct method of answering and doing a calculation question. Okay. All right. So let's see. Alamak, where's my pointer? Okay. The mass is actually 67 kg. Okay. Find the surface of Earth. The gravitational field strength of Moon is 1/6 of the gravitational field strength of Earth. Earth's gravitational field strength and the acceleration is actually the same value, 9.81 meter per second squared. Okay, so in order to find the weight on Earth, all right, it's actually the mass on Earth multiplied by acceleration due to gravity on Earth. So that would be 67 kg multiplied by 9.81 meter per second square, and your calculator should give you 657.27. The weight unit is actually Newton. Okay, so that is the first part. The second part, if you get it correct, please directly use a red pen and mark your book straight. All right, for this particular working. Get a red pen or any other colored pen, not the one that you wrote. All right, directly mark it in. All right, the second one is the weight on the surface of Moon. So weight on Moon, again, mass multiplied by acceleration due to gravity on the Moon. Now, because of this particular statement, the mass multiplied by 1/6 of acceleration due to gravity of Earth depends on how you do it. You can substitute in again, or 1/6 of the weight on Earth. So then you substitute 1/6 times 657.27, anyhow method, and your answer should be 109.55 Newton. All right, so this is the proper method in order to write the answer. Okay, so I'm going to check if Frank's working right now. All right, so here now, when you do a calculation question, it is very important that you write the formula first. All right, because sometimes formula got 1 mark, and then only you substitute. All right, then only you substitute the answer, where sometimes it also has 1 mark. And finally, the final answer, make sure there's unit. Then only you can get the final answer marks. All right. So for Chuan Wei, there's a missing formula here. So if this is a 3 marks working, Xing Yu, give me a minute. If this is a 3 marks working, Chuan Wei, you only get 2 marks, Okay, this is 2 marks in SPM. But if in exam, I might give you 0. Because without the head, without the formula, the body and the tail doesn't work. Okay? And then over here, no working again. Okay, Chuan Wei, so please make sure that you write the formula in. The rest of you, look back at your own working. Okay, the formula is given in SPM, all right? They do give it, but in that particular question, you need to know what formula you're using. Because in physics, there's a lot of formulas, all right? But the thing is that for this particular question, what formula you're using to solve your question? All right, Justin, so please make sure, write your formula. You're now in Form 5. You're not in Standard 6. You're not in Form 3. All right, so in the lower forms, there's no formula. They only look at the final answer. But as you grow older, these are the details that needs to be taken care of. All right, so don't skip this. All right, because of Xing Yu request to show my working. So I'm showing my working right now. You will notice one thing is that every single time I do a calculation, I will always write formula, then I substitute, then only I'll get my final answer with unit. Xing Yu, okay? All right, so I'm going to proceed. Let's go to the next one. Chan. This is not Justin Chan, is it? Or another Chan in Omega or another class. So this one definitely salah because unit pun dah salah. Okay. So this one definitely kosong already lah, huh? Alright, Jonathan's working. Formula is there. Substitution is there. Final answer with unit. Good. Here, formula, substitution, answer unit. Alright, good job, Jonathan. Zijing, no formula. Formula missing. You get marked for the substitution, but your answer tak ada unit over here. So out of 3 marks, you only get 1. And then here, honestly to say, I have no idea. The minute I see this, I will just directly give 0 already. Because there's no formula, the work looks messy. I have no idea what you're doing. Alright. The rest of you who have this similar working as Zijin, please correct it. Okay? Alright, Cheryl. Cheryl, again, no formula, missing. You get marks for the substitution. You get marks for the final answer with unit, so that's 2 out of 3. Again, here, no formula. Substitution got. Answer unit got. So this is again 2 out of 3. Now, the reason why I picked Cheryl's working is because of here. Alright, decimal places. If you would notice, this is the reason why I look at your working is because I want to have technique menjawab together as the class as well. Now, for decimal places, normally is 2 decimal places maximum. Alright, maximum 2 decimal places. Alright, 3 decimal places sometimes we accept, but try not to go until 3. Okay? Alright, so let's proceed. Okay. Now we're going to continue. What is normal reaction force? What do you understand about normal reaction force? I'm giving until 3-minute marks, maximum 3 minutes. So try to find what is normal reaction force, what you understand about normal reaction force. "30 seconds before I cut off the submission." "10 seconds to go." All right. All right, so most of your answers are Google answer if I'm not wrong, because all the answer looks like the same. Perpendicular to the surface, good. A force that is acting perpendicular to two surfaces in contact with each other. All right, good. A force that goes upwards from the center of the object. Upwards, normal reaction force. Okay. Perpendicular, perpendicular, perpendicular. All right, good. All right. Now, so normal reaction force, okay? Normal reaction force is actually the force that exists whenever two solid surfaces are in contact. So if let's just say right now, hey, look at my pen that I'm holding at in front of my screen. If you can see me now, okay, or you can look at any object in front of you. If you were to hold your pen in the air, is there any normal reaction force? If you say no, then you could be wrong. Because one thing, our fingers are actually a solid surface as well. So when we hold a pen, apart from the weight of the pen, there is normal reaction force every single time we touch something. Or if the object is placed on the table, there is still normal reaction force. Right? And I'm happy to see that some of you actually stated the word Newton's third law. Yes, because normal reaction force is there when there's a Newton's third law of motion. All right, when an object is placed on a table, the weight will always be acting downwards. If there is no normal reaction force, the book will actually submerge and go straight down to the center of Earth. But it doesn't go straight down. You and me sitting on the chair, you don't go straight down to the center of Earth. Why? Because of normal reaction force. Okay? So the direction of normal reaction force, like what most of you have stated, is always perpendicular to the surface of the object. But one particular thing is that it's not always upwards. Okay? It's perpendicular to the surface of the object that is in contact. All right? So like this. If it's horizontally on the object, normal reaction force is pointing upwards. But if it's on the inclined plane, all right, an angled plane, normal reaction force is perpendicular to the surface in contact. So always remember, normal reaction force does not mean that it's always going upwards. It's perpendicular to the surface of the object that we're talking about. The unit for normal reaction force, because it's a force, the unit is still Newton. All right? Because it's a force, the unit is still Newton. Always remember, electric force, magnetic force, electromagnetic force, nuclear force, chemical force, or whatever force, weight, tension, friction, as long as a force, the unit is still Newton. Okay? Now, remark, normal reaction force does not always have to be the same as the weight. This is one misconception that students always have. They always think that normal reaction force equals to the weight. Not always. It will only equals to the weight in this condition, when the object is flat on the surface, on a horizontal surface. Now, next, we're going to go into, anyone writing this? Can I proceed? Can I proceed to the next slide? Again, as I remind you guys, even though this is not part of the syllabus, but it's a basic knowledge that you need to know, because it was learned previously in the lower form and it has been taken out already. All right. So I'm waiting for at least Cassandra and Elina right now. Cassandra done. So I'm waiting for Elina. Okay, good. I know my pace could be could be a little bit slow for some of you guys, especially those in Gamma and some student in Alpha. When we are back to physical learning, it's going to be based on your class. So right now, I have to wait for students from Gamma, Omega, and Alpha. All right. Now, next force that we're going to talk about is actually tension. Tension is the force when there is in the cord that pulls an object. For example, let me search for an example. Ayman, yes, I will post the recording. Actually, I will upload in YouTube. All right, I will upload in YouTube because it's easier to access. I will send the link out. All right. So this is actually a wire. All right. It doesn't have to be a wire. It could be a thread. Can you please look at my video? All right. Look at my webcam. All right. Not the PowerPoint slides. Look at my webcam. Give me one quick minute. Okay. All right. Try to look at my webcam. Okay. You have to adjust from your view. All right. So as long as it's a cord, it's a string or it's a wire, it will actually have tension. So let's just say I have my card at my string. Okay. When I have my card and my string, I have no idea what's wrong with my class point right now. Okay, give me a quick minute. Mm, okay. I seriously have no idea what's wrong with my. Okay. So back again, all right. So when my card is like this particular object here, all right, like this particular object, it's hanging by a wire, all right. So the tension is actually the force that is at that particular cord, that wire, that string itself, all right. So tension force is actually at the cord, all right, and it's always directed away from the body. So in this particular diagram, you see that it's actually directed away from the wall. So which means that they are talking about the tension that is felt by the wall. But if you're talking about the block at the bottom, the tension is moving upwards, away, but along the cord, along the wire, along the string. So that is how tension is considered. So again, tension, because it's a force, therefore the SI unit is still Newton. The cord, normally we ignore the mass, because if we include the mass, it's going to be a very difficult stuff for SPM students. We assume that it's unbreakable, it's unstretchable, and there's no friction on it, right? We ignore the mass because, or else we have to include the weight. It's unbreakable because at certain limit it will break. Cannot stretch because the minute if it's stretched, we have to include about elasticity force. All right. Frictionless also because we don't want to consider the frictional force that exists. Okay. So the tension pulls at the either end of the attachment of the same magnitude. All right. So the red color value and the blue color one, they has the same tension value. So example of a cord would be a string, a chain, a wire, a cable, or anything that's a straight line that can hang something. All right, even the chain on our necklace that has tension as well. Okay, so that's tension. All right. Again, I'm giving you guys anyone's copying or you want to refer back. That's up to you. I'm changing slide in 5, 4, 3, 2, 1. All right. So next is actually talking about friction force. All right, friction force is something that you guys keep seeing a lot of time. So what is friction force? Closing submission at the 2.5-minute mark. So you have 30 seconds left. And I repeat, Iman's question, I will record this and I will post it up in YouTube so it's easier for references. "15 seconds to go. "5 seconds to go. All right, so now let's look at your answers. Yeah, post the PowerPoint slides in GCR. Okay, sure, no problem. Okay, now, my question is, what is friction? A force that resists the sliding or rolling on one solid object over another. Okay, so the keywords that I'm seeing right now is resisting, sliding or rolling on one solid object, okay, over another, resisting the relative motion of solid surfaces, okay. Daryl and Jaslyn, the word solid means book solid. So if I'm talking about liquid, does it not consider friction? Or air? There's air resistance, right? So yeah lah, sometimes it depends on your understanding also, and also what the internet writes. So friction force acts on a rough surface. Okay, good. Created opposing force type of motion, something that slides or rolls. So frictional force, object sliding, opposing. Okay, let's see. Most of the answers is all the resisting motion when it comes in contact. Okay, this is a good answer. Force that resists motion when the surface of one object comes in contact with the surface of another object. All right, that's a good answer. Okay. I notice I'm speaking a bit loud for the next door class already. Force that have an object sliding over exists when two surfaces in contact. Friction is the force resisting the relative motion of there. Justin, mana mungkin level kosong lah, Justin. Friction is the force resisting the relative motion of solid surface, fluid layers, materials sliding against each other. Okay. Coefficient force increase, normal force decreases. Wow, seeing you a bit advanced. Jamun's in my class. Friction is a force that resists motion when the surface of one object comes in contact. Okay, good. All right. Okay, most of the answers are all generally the same. Now, so friction force is a force that resists the motion of a body as it slides over a rough surface. Okay, so it actually means that it's the force when an object wants to move, even if it doesn't move. All right, friction is there. That's the reason why you are actually sitting on your chair nicely or lying on your bed nicely, but you're not sliding away. Friction force is the one that resists your motion, okay, over a rough surface. Now, the direction of friction is parallel to the surface in contact, and it's opposite the direction of motion. So if, let's just say, this particular box is moving towards the right, the motion is towards the right, friction will be moving towards the left, okay? So in your SPM syllabus, always take note whether they say on a frictionless surface or there's a value of the friction. Okay, they will state, in order to minimize student problem, they will say that an object is moving on the road on a frictionless surface. So which means we don't have to include frictional force into your calculation. Okay, but if you do, always remember friction is opposing the direction of motion. Again, unit for friction, because it's force, the unit is still Newton. Now, why does friction exist? Even if you go to Sunway Pyramid, you go to the ice skating rink, there is still friction on the ice rink. Why? Because of the micro surface. All right, on the micro surface of the layer, The origin of the surface is that no one surface is a perfect smooth surface, not one single surface. Okay? When viewed at the atomic level, right? Atomic level means the atom, electrons, proton level. Even the smoothest surface is actually rough and jagged. Because atom they won't nicely be a one flat straight line. Okay? It's still rough and it's still jagged. So this type of roughness contributes to the friction. Okay? Force is required to overcome the microscopic hills when the surface slide across each other. This is the main reason why there's friction. Even if you were to put oil on the surface, you still can walk nicely slowly on the oil. If you walk fast, you will definitely slip down. Alright, but if you were to walk slowly, you will not slip. Why? Because at the microscopic view, the atomic level, there's still friction over there. Okay? Now, factors affecting friction, again, just a general knowledge, type of the surface in contact, how hard the surface are pressed together. Friction force is actually directly proportionate to the normal reaction force. The stronger the normal reaction force, the stronger the friction. Okay? So this is general knowledge for you guys. So the foot tries to slip in this direction, the friction acts in the opposite direction. Okay? Motion of a car, the wheel turns in the backwards direction, the friction is actually moving towards the front. Now, in order to increase friction, there's one particular thing. In order to increase friction, the tire of the car will actually have to be there's pattern on the tire of the car, similar to your slipper or your shoe. When the padding, not the padding, what do you call the bottom part, the surface of the shoe, when there's a lot of patterns over there and deeper the patterns, the how to say, it's even difficult for you to actually slip because the friction is actually quite high. Ah, is it sole? Sole is inside, right, Justin? Sole is the one that's inside, right? Not the outer part. The outer, the bottom part that touches the floor. All right. So please take note. In order to increase the friction, you need pattern on the tire or the shoe. And once there's friction, your acceleration will decrease. All right. When the friction increase, how you increase it? By having patterns on the tire or the shoe, then your acceleration will decrease. All right. So please take note about this sentence. Okay. Up to here, are you guys okay? Up to here, are you guys okay? I'm going very slow and easy, so I hope that all of you can understand this. Now, free body diagram is definitely in part of your syllabus in Form 5, but it's supposed to be taught after resultant force. I'm teaching it before the resultant force. What is a free body diagram? Go back 2 slides. This one, Faraj? This one. Again, I'm telling you, I will let you know which is actually in your syllabus, which is outside of your syllabus. One more. This one. There's no remark because I removed the remark. The remark is a bit too higher standard from you guys. This is actually a notes that I created last time, long time ago. So I'll tell you guys which is for your information, for your better understanding, or which one is actually in your syllabus, okay? And when I ask to emphasize, if I emphasize, I ask you to remember, I ask you to take note, that one you all pandai lah, okay? If you still choose not to listen or try to AFK, again, the choice is yours because your SPM result is yours. Jarash, are you done?
Yeah.
All right, good. So I'm gonna fast forward this. All right, free body diagram. Now, free body diagram is actually a simplified diagram in physics or science that shows all the forces acting on one object. Okay. Chok, Aiman asks, does a corrosion on a metal like bearing, does it give more frictional force than a normal one? I have to search this or Aiman because I'm not very quite sure. You can try to Google search and see. All right. But I'm sorry, at this particular moment, I have no answer to your question. Does a corrosion on a metal like a bearing, does it give more friction than the normal one? Copy and paste that question in WhatsApp so that I can check later. Okay. Now, back to free body diagram. All right, a diagram that shows all the forces, and we're talking about forces only. We're not talking about weight. We're not talking about mass. We're not talking about pressure, volume, or whatsoever. Only force. All right, free body diagram is a diagram, a simplified diagram to show all the forces acting on one object. So how do we do a free body diagram? The object, irrespective of whatever object it is represented by a point or a box. All right. And the force of arrow is drawn from the center of the point or the box outwards in the direction of the force acting on it. Okay. So again, whatever object it is represented by a point or a box, and then the force is drawn away outwards, all right, in the direction of the force acting on it. So an example, the direction of arrow reveals the direction in which the force is acting. That's the reason why from the first slide I tell you that force is a vector quantity. Vector means magnitude and direction. So the direction, every single slide, if you look back into your notes that you've written down, every single force I tell you where the direction is. Weight pointing downwards to the center of Earth. Normal reaction force perpendicular to the surface. Tension along the chord away from the object. Friction opposing the direction of motion. All right. Actually, there's a fifth force that you need to know. That is the applied force from us human. We human either pull or push that particular object. Okay. Now I'm gonna go next slide already. Now, example of this. Try, all right, try on your notebook, try to identify first before I show you the actual answer. Identify, draw this box that's on a rough surface. As you can see, this is a rough surface. Draw the free body diagram, all right? Let's see how you do. Draw the free body diagram of this particular box. Jarash, let me know if you're done with this slide so that I can go back to the one. My tips for you guys, if you want to draw the forces, number one, identify the type, how many forces acting on it. Then only you represent the box as a point, and then you draw the arrows. I'm giving another 2 more minutes before I close submission. Thirty seconds left before I close submission. Right. So I've saved some of the friends working over here. I pray hard that my pointer got no problem. Good. Okay. Now, actually, one thing. This particular question that I gave you is quite open-ended. I think that's one of the reasons why some of you had quite a long time in order to answer this particular questions, because number one, I did not mention about the direction of motion. I only mentioned that there's friction. The surface is rough. Okay. So it's quite open-ended, and I actually look at how you guys actually interpreted the thing. So I only told you there's a box on the rough surface, and draw the free body diagram. Okay. So number one, there's no direction of motion for this particular object because I didn't state any of it. So if it's just a normal object, it will be the same thing that if you look around you, your book on the table. All right. So number one, to represent the free body diagram, I draw a point. There is always, 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 as long as on Earth, there is always weight pointing straight down to the center of Earth. All right. You can actually write W, or you can label it as capital F, then subscript W. That's up to you. All right. Then because it's touching the surface, there will be a normal reaction force pointing upwards. So I'm going to label that as N, normal reaction force. Now, but please take note one thing. Force is a vector quantity, and I'm sure you have learned vector before in your mathematics. When you learn about vector, all right, when you learn about vector, you know that the arrow shows the direction. But please also remember that the length of the vector line represents the magnitude. Okay? So when an object is actually on the table, it is not floating up, it is not being attracted down towards, moving down to the center of Earth. It actually means that the weight and the normal reaction force is the same. So the length of this particular two force technically should be the same. Okay? So if you interpret this particular box as static, not moving, this is the only two forces that is on the object for SPM level. Okay? But if you were to consider this box can actually move towards the right, right? Which I notice most of you moving towards the right, mainly possibly because the table is actually there's more space towards the right hand side. If you consider this as a moving object, okay, so in order for it to move to the direction of motion, all right, for it to move towards the direction of motion, there need to be an applied force. All right, this applied force will normally be Earth, okay? And then because it is moving towards the right, there will always, because it's on a rough surface, I already mentioned it's a rough surface, so there will be a frictional force that is applying towards the left hand side. All right, so it's either just the y-axis, the normal reaction force and the weight, or if you consider that it's moving, then it's going to be applied force to the right and friction force to the left. So I saw some of you, let's go to your working. All right, so Putri has the thrust towards the right and the drag towards the back. Now, let's all understand one thing. Thrust will always be upwards. Okay, not necessarily. Let me erase this off. Thrust doesn't always go upwards. Thrust if there is engine. But this is a box only. So a thrust force only can be coming out from an engine. Alright, Putri? So drag is normally when it is at air resistance. Alright? So normally if it's a solid surface, it's friction. Alright, Putri? The rest of you also please take note. But your y-axis, okay, there's a lift here. Because the box is not moving up, so this lift is not applicable. Okay? Kavina Rasi, okay. Would the magnitude of the frictional force be equal to the applied force? Now, that will actually depends on whether there is acceleration or not. If there is acceleration, it's not equal. But if there's no acceleration, then it's equal. We'll go into that next week. Okay, that's the resulting force that you guys were supposed to do for your game homework yesterday. All right, free body diagram, Justin's work. Okay, Justin, your normal reaction force, your y-axis is correct, but your frictional force, this part is actually not accurate because free body diagram needs to be outwards, like this. All right, Justin, please take note. It's supposed to move away from the object. All right. Parani, mana datang tension? Is there a cord, string, wire, cable? Don't have, right? If don't have, then there's no tension. But the rest, weight correct, reaction force correct, frictional force correct. So Tarani, please take note. All right. Li Xuan should assume that it's only static, so weight downwards, normal reaction force upwards. Okay, here. All right, Clement, apa itu F1, F2, F3, and F4? I want to know the label. Nadira, frictional force. Frictional, normal, gravity, applied. Okay, I can accept this. Jiajun, normal reaction force. You assume there's a motion, so there's a friction and gravitational force. Now, Jiajun, if it's moving towards the right, there's no force pointing towards the right, so how it moves towards the right? Jiajun, you understand my question? If you say that this box is actually moving towards the right, but there's no force pointing towards the right, how does this particular block on a rough surface can continue on moving towards the right? It can only move towards the right if there's a force pointing towards the right. All right, go and open back after this over the weekend. Open back the activity game that I posted in GCR. explore that. All right, so there. Okay. Put only the main forces for free body diagram and not the resolving forces. Resolving forces is, I'm going to teach that next week. Okay. So that is about free body diagram. Are you guys okay with the free body diagram? Just last slide before I end the class. Hopefully okay, Don't say no problem, but then after that come back to school, you guys blur blur, Alright. Now I asked you guys to actually do the activity, the simulation activity that I posted inside the Google Classroom. There's only like 20 plus that I just checked just now. Please do go back. Alright. So today's class was an introduction and the free body diagram. Next week I will go detail into the resultant forces. Those who haven't finished the activity, please do so. Yuanming question, the force must be pointing outwards. If we are drawing a free body diagram, the force must point outwards. It cannot point into the object. Free body diagram force must point upwards. Now, resultant force, this is the last slide before I end the class. Resultant force is known as a net force, sum of the forces, total forces. I repeat, resultant force, apart net force, it also known as the total force. It can also known as the sum of the forces. All right, meaning means whatever total conclusion. Okay, so the net force is the overall force. This definition, take back the definition from your class, your textbook. It's the overall force that is acting on the object when all the individual force acting on the object are all added together. All right. So objects normally have more than one force acting at them at one time, except an object free falling. Even if free falling on Earth, apart from weight, there is still air resistance or drag. Okay, so at least there will be one, but normally it's two, as long as you're on Earth. So if both of the forces are acting in a straight line, we can add or subtract the forces to show the overall effect of the object called the resultant force. All right, so this is a quick intro of resultant force. Now, what I need you guys to do over the weekend, number one, finish up the activity in the GCR. Number two, all right, one is the GCR activity. Number two, go back, find information, and relearn your vector in mathematics. All right, relearn your vector in mathematics because force is a vector quantity. So it's a vector, you have to understand vector. Go back, look back at your vector, then you'll be able to understand next week class. Okay, so I'm going to stop the lesson here. All right, one last question. Does the gravitational force from the center of Earth from the surface pointing inwards or outwards? If we are drawing a free body diagram, all right, if you're drawing a free body diagram, it will always point downwards towards the center of Earth. All right, always point downwards. So when we're drawing a free body diagram, it will always point downwards, away, upwards. Okay, Aiman? All right, any other questions?